Welcome to the another experiment of electrical lab. This experiment is based upon the three-phase induction motor. In this experiment, we will do the direction. We will change the direction of the rotation of the induction motor. So the aim of the experiment is here to study the running and speed reversal of three-phase induction motor and measure the speed in both the directions and also find the percentage slip. Right. So this is the aim of the experiment. So what we need for performing this experiment is definitely we need a three-phase induction motor. In our experiment, we are using a squirrel cage type of induction motor, three-phase induction motor. We need a direct online starter, DOI L starter, and the theory part of this is given in front of you. The theory portion of this says that your three-phase induction motor rotates on the when three-phase supply is given to the induction motor, the three-phase magnetic field is produced and your motor start rotating. So your motor never rotate on the synchronous speed. Now synchronous speed is given by this formula, Ns is equal to 120F by P, where F is the frequency, P is number of poles. So here number of poles are 4, F is 50, so synchronous speed is 1500. Okay, so next task is to find the slip. Slips, as you studied in your theory classes, that is Ns minus Nr, where Ns is your synchronous speed and Nr is the speed of the rotor. Okay, generally the slip is represented in terms of the percentage, so we will divide it by Ns and multiply by 100 so that we can represent our slip in percentage. Okay, so this is the circuit diagram for your direct online starter. This is a simple diagram. It looks complicated but it's not. Here RYB, the three-phase, you can say the supply is given from these terminals. This is the two buttons for the direct online starter. Shortly I will show you. When you push this button, this coil is energized and this circuit is started and your motor start rotating. Okay, so to rotate the motor in the another direction, once it rotates in clockwise direction, if you want to rotate it in the anti-clockwise direction, you will just change the sequence. Here for the clockwise we are using RYB. For anti-clockwise you can use RBY. So let's move to the experiment. We will take the help of Mr. Jesse, lab technician with us. So first we will show you the direct online starter. This is your direct online starter. The circuit diagram I have shown to you. From here the three-phase power supply is coming. This is your three-phase power supply. This is given to the direct online starter. So there are two buttons. We have energized this with the black button. We push this button, your motor is already started. So this three-phase supply from the starter is coming to the motor terminals. Here are the motor terminals. RYB sequence are there. You can see the sequences RYB. Here we have the device tachometer, which is used for measuring the speed. So now you can see that your motor is almost running synchronous speed 1499. Okay, so this is a digital tachometer. Or you're using this digital tachometer. So this is the speed of the rotor. So speed of the rotor is measured. Now we want to rotate it in the opposite direction. Okay, so for rotating, now it is rotating in the clockwise direction. So suppose you want to rotate it into anti-clockwise direction. Now I have just stopped this button and we are changing the phase sequence. Look here, we are changing the phase sequence. Earlier it was RYB, now it will be RBY. Okay, so I have changed the sequences of the phase so that our motor starts in the opposite direction. You can see that now it is starting rotating in the opposite direction to the previous direction. Again you will measure the speed. So speed is coming out to be 1500. So almost rotating at the synchronous speed.
1499.
Okay. So the units are RPM.
1499.
1499 revolution per minute. So this is all about this experiment. Hope all of you understand this experiment. Thank you, Jai Singh ji.